Alright, today I'm going to teach you how to mathematically model waiting times using independent random variables with double integrals. So before I get there, I must cover some conceptual grounds. Imagine that you have two random variables x and y. Furthermore, suppose that each random variable is a probability density function. So for x, we would denote it as this. This is a probability density function of x. And for our other variable, y, it would look like this. Now remember, these probability density functions are independent of each other. That is, x does not convey any information about y, and y does not convey any information about x. They're individual, they're independent. So, for example, the time it takes a cook to make a pizza is not dependent on the time it takes the delivery boy to reach his destination. In this scenario, our probability density function x could equal the time it takes for the cook to make his pizza, and our probability density function of y could be the time it takes the delivery boy to get to his destination. If you think about it, this makes sense because the cook cannot make the boy floor the pedal to get to his destination faster. They're independent of each other. So could we make two random variables into a joint density function? Of course we can. Indeed, x and y are called independent random variables if their joint density function equals the product of their probability density function. So this is what this will look like if we were to write it out. The joint density function equals the product of the two individual probability density functions. And when it's in this equation, we call these independent random variables. Now, another concept that you must remember from Calc 1 or Calc 2, where you used single integrals to find probability, is how to model waiting times using exponential functions. If you remember, there's a formula that looks something like this. There's a function of t, it was a piecewise function, and for anything less than, if the time was anything less than 0, it automatically equals 0, which makes sense. We can't have any negative minutes. Also, we have the mean waiting time times some exponential function. And this is going to help us model waiting times, this exponential function right here, where this mu right here equals the mean waiting time. And this is if the time is greater or equal to 0. So what we're going to do is we're going to find probability with independent random variables using double integrals. Now think about it. Since we can use double integrals, we can do this. We can use two variables that do not depend on each other because now we're in Calc 3 and we're in 3 dimensions. And we can use functions that have more than one variable. So this problem, I'll read it. Suppose that you are at Six Flags and the Goliath has enticed you to stand in this line. Now imagine that the average waiting time for the ride is 30 minutes. Also, imagine that a second waiting time exists for seatbelt operations, and this time is 6 minutes. If we assume the waiting times are independent, find the probability that you will wait a total of less than 40 minutes. Okay, so we have two probability density functions that I just said in this question. The first one is the waiting time for the ride, which is 30 minutes. We're going to call this x. Okay, so the first one is f of x equals 30 minutes. That's our first probability density function. Our second one, which is independent of this one, is we're going to give it the y variable, and it's going to be 6 minutes, because that is how long it takes for one to put on a seatbelt.